In this video, we're going to go over how to graph a linear inequality. Now, if you remember, when we graphed inequalities before, we made one number line, we had to put an open or closed circle, and we shaded, and the shaded area was where all the answers are. Those type of inequalities had one variable. The type of inequalities that we're going to go over are going to have two variables. And remember, the reason we graph these is so that we can find the solutions to these inequalities. So, a linear equation is sort of like a linear inequality. A linear equation, the solutions are points that are on the line. So if I take this linear equation, y is equal to 2x plus 1, what form is this in? This is in slope-intercept form. To find the solutions, what I need to do is graph this. So I'm going to graph this. How do I graph something in slope-intercept form? I graph the y-intercept first, put a point at 1, then I use the slope. The slope's telling me to go up 2, 1, 2, over 1, and then I draw a line. All the points on this line are solutions. For example, if I take this point right here, which is you don't go over any, and you go up 1, that would be 0, 1. That's a solution. So what I could do is to prove that this is a solution, I could use the formula up here and put these numbers in the right spots. Y is equal to 2x plus 1. What I'm going to do is I'm going to plug these numbers into this, and I'm going to show you that this is a solution. My y coordinate is 1 is equal to 2 times 0 plus 1. 1 is equal to 0 plus 1. 1 is equal to 1. This one is a solution. Something that's not on this line is not a solution, like 0, 0. So we're going to do this when it's got 0, 0. We're going to see if 0, 0 is a solution to this. Plug these numbers in here. 0 is my y. 0 is my x. 0 is equal to 0 plus 1. 0 is not equal to 1. This one is not a solution. This one is a solution. And the way I proved that was to plug those numbers into the equation. So all the points that are on the line are solutions. When we have a linear inequality, remember, we're going to have to shade somewhere, because not only are the points that are on the line, not only could those be solutions, but I could have solutions in other areas that are shaded. So what we're going to do is we're going to graph this just like we would a normal equation. Even though it has this inequality symbol, we're going to graph it just like we would the other one. What form is this in? It's in slope-intercept form. I'm going to put my first point at my y-intercept. Then I'm going to use my slope. My slope's telling me to go up 2 over 1. I draw a line. Points on this line are solutions. For example, I'm going to try this point again, 0, 1, and I'm going to plug it into my inequality. Y is 1 less than or equal to 2 times 0 plus 1. Y is less than 0 plus 1. 1 is less than or equal to 1. Yes, this point is checking out. But I also need to check points on either side of this, because what we're going to do with one of these is we're going to shade in one of these areas above or below this line and show that I have other solutions in these other areas. On a line, these points above and below the line can't be an answer, but on this one, it can be. So we're going to check a point like we did before, 0, 0. Y is less than or equal to 2x plus 1. I want to plug these numbers in here. 0 is less than 0 plus 1. 0 is less than or equal to 1. Yes, Not only are we have points that are along the line that are solutions, we've got points that are below the line that are solutions. So what we're going to do on these inequalities is we're going to shade this entire area over here, telling everybody that these points over here are solutions. So let's go over the rules for this. Here are the rules on how to graph a linear inequality. We've got specific rules on these. First off, graph the inequality as if it was a line. Even though it has an inequality symbol, graph it like you normally would. For example, if it's in slope-intercept form, graph it using the rules for slope-intercept form. For example, this is in slope-intercept form. Here's your formula. This inequality is in slope-intercept form. Use the slope and use the y-intercept to help you graph this. If it's in standard form, like this right here, use the x and y intercepts to help you graph those. So first off, graph the inequality as if it was a line. Step number 2, you need to look at the inequality symbol. The inequality symbol is going to determine what type of line you draw, because sometimes it's going to be a solid line and sometimes it's going to be a dashed line. If it has these symbols, a less than or a greater than symbol, then you're going to use a dashed line. If it has less than or equal to, greater than or equal to, then you're going to use a solid line. So these symbols are going to tell you what type of line to use on the graph. Next, you need to determine where you're going to shade, just like all inequalities. You're going to shade where your answers are. So what you're going to do is you're going to pick a test point on either side of the line to determine where the shade. And remember, the shaded area is where all your solutions are. So, if you pick a point above or below the line, it doesn't matter, and you work it out, and you determine that that point works, that it's true, then you're going to shade to that side. If the point you picked did not work, which is false, then you're going to shade on the opposite side. So you pick a point on one side of the line, that's your test point, and you test that point. If the point's working, then all the points on that side of the line are going to be solution. If you use that test point and it doesn't work, then your answers must be on the other side of the line. What we're going to do now is work out some examples following those rules. Rule number 1 says that I need to graph this just like it's a line. So just like a line, I need to see what form it's in. That's going to tell me how I'm going to graph it. This is in slope-intercept form. Something's in slope-intercept form, I graph my y-intercept first. Y-intercept is 1. Then I use the slope. The slope is 2. That's telling me to go up 2, 1, 2, over 1. Once these 2 points are graphed, then you need to determine what type of line. A dashed line means the points along the line are not solutions, just like an open circle. A solid line means the points along the line are solutions. And what type of line is determined by this symbol right here. This symbol means we're going to put a solid line. So we're going to draw a solid line. Next, we need to determine where we're going to shade. A good point to use, because we need a test point, is always 0, 0. If it's not on the line, use 0, 0 as a test point. So that's what we're going to do. We're going to use 0, 0 as a test point. And we're going to use that point. If the point works in this inequality, then I shade on that side. If it doesn't work, then I shade on the opposite side. So let's use 0, 0. 0 for my y and 0 for my x. 0 is greater than or equal to 0 plus 1. 0 is greater than or equal to 1. Is this true? No, it's not true. That means I need to shade on the opposite side over here. All these points on this side right here are solutions to this inequality. So our steps again: determine what type of form this is in, use that to help you graph it, use the inequality symbol to determine whether it's a solid or dashed line, and then use a test point to determine where you're going to shade, where all your answers are going to be. Our next example, we're going to graph this inequality. First thing I need to determine is what form it's in. This is in standard form. When it's in standard form, I'm going to use the x and y intercepts. My x-intercept, remember, if I'm going to find the x-intercept, I don't need the y. Looks like my x-intercept is going to be 1. So on the x-axis, I put my first point at 1. My y-intercept, I don't need the x. Looks like my y-intercept is also 1. Once I graph those 2 points, I need to look at this symbol right here to determine what type of line. That right there means I'm going to put a dashed line. So that's what I'm going to put. I'm going to put a dashed line. That means points along this dashed line are not solutions. To find the solutions, I need a test point. Again, a good test point is 0, 0. It's easy to plug 0, 0 into these inequalities. So that's what we're going to do. We're going to use this point to see if we need to shade on this line. If this point works, I shade on this line. If it doesn't work, I shade on the other side. So let's do that. Let's use 0, 0. 0 for my x, 0 for my y. 0 plus 0 is 0. Is 0 less than 1? Yes. That means I need to shade on this side right over here. That means all the points on the side of that dashed line are solutions. This is the way it's easy to find solutions. I can pick points. Before I would have to pick points and try each one of them and plug it in there. Now I can look and see. Points over here are solutions. Points over here are not solutions. We need to graph this inequality. And remember, our first step is to graph this like it was a line. Remember, we have horizontal and vertical lines. That's what one of these are going to be. If it just has an x or just has a y, it's going to be horizontal or vertical. So I'm going to put my first point at x is negative 2. So x is negative 2. And now I need to draw a line that does not touch the y-axis because there's no y's in this. What kind of line is it going to be? It's going to be a solid line based on that inequality symbol. Now I need to shade. To shade, I need a test point. I'm going to use 0, 0 again. So, x is greater than or equal to negative 2. I don't have a y to put a 0 in, but I have an x. 0 is greater than or equal to negative 2. Is 0 greater than or equal to negative 2? Yes. That means all my points on this side right here are solutions. And I need to shade that side right there. All the points on this side are solutions. All the points on this side are not solutions. Remember, my first step is to graph this like it's a line. Remember, you have horizontal and vertical lines when you have only one variable. This says y. So I need to put my first point on y. In fact, I put it at positive 3. 1, 2, 3. Now I need to determine what type of line it's going to be. Is it going to be a solid line or a dashed line? I look at this symbol right here and it's telling me to make a dashed line. And I make a horizontal line because it should not touch the x-axis. There are no x's in this inequality. Next, I need a test point. The test point we're going to use almost every single time, unless it's on the line itself, is 0, 0. So y is less than 3. There's no place to put 0 in x, but I want to put it in my y. Is 0 less than 3? Yes. That means all the points below this are solutions. That means I need to shade everything below that line. Next example. First thing I need to do is graph this like it was a line. What form is this in? Slope-Intercept Form. To graph something in Slope-Intercept Form, I need to graph the y-intercept first. The y-intercept is usually out here. What's the y-intercept? There's nothing. What number represents nothing? That would be 0. I put my first point right there. Then I need to use my slope. What's my slope telling me to do? It's telling me to go down 3, 1, 2, 3, over 1. Now I need to determine if I put a solid line or a dashed line. This symbol right here is telling me to put a dashed line. So let's put a dashed line. Now I need to shade to determine where my answers are. Right now it's using the point that we would normally use, 0, 0. So I have to pick another point, like this one right here. I'm going to use 1, 1. 1, 1 is another easy point to use. So y is less than -3 times x. I put a 1 for my y and put a 1 for my x. 1 is less than -3 times 1, -3. Is 1 less than -3? I'm using this point right here. Is 1 less than -3? No. That means I need to shade the opposite of that. Points on this side are solutions. Next example. I have to determine what form this is in because I want to graph this like it's a line. This is in standard form. If something's in standard form, I use the x-intercept and the y-intercept. The y-intercept is going to be easy because it's almost like I cover this up, and my y-intercept is going to be 1. However, my x-intercept is going to be a fraction. If I divide both sides by 3, that's going to be a fraction. Therefore, it would probably be a good idea for me to change this into slope-intercept form. So some of these you're going to have to change into slope-intercept form because you can't use the x or the y-intercept. So I'm going to subtract 3x from both sides. Y is greater than -3x plus 1. This is what I'm going to use to graph this. My y-intercept is 1. My slope is -3. That's telling me to go down 3. 1, 2, 3 over 1. The next thing I need to determine is what type of line it's going to be. Since it's using this symbol right here, it's going to be a dashed line. Now I need a test point to see which side I'm going to shade. 0, 0 is always a good test point. I'm going to plug it into this formula right here. -3 times 0 is 0. 0 plus 1 is 1. 0 is greater than 1. Is 0 greater than 1? No. Do not shade on this side. Shade on the opposite side of that. All my answers are over here on this side.